Hello, welcome to this lesson video for adding and subtracting rational expressions. This is our second part, so our examples are going to be kicked up a little more than that first video, part 1. One thing to remember from the previous lesson video is that we need common denominators to be able to add or subtract our fractions. So when we look at these rational expressions where they have x's, we kind of have to remember the difference between a single x and a married x. Remember the different status that they could have. This x is married because it has a -3. This x is married because it has a +2. So technically, since these are two married groups and they're different, we cannot say that these two fractions both have an x in the denominator. So that's important when we start thinking about a common denominator we need to get. Technically, the first fraction has the group x -3, but it needs to gain the group x +2. So when you make common denominators, you can't drop something. You can only increase to it, make it gain something. So that second fraction has x +2, and it needs to gain what it was missing, the group x -3. Okay. So this would be my common denominator that I want both fractions to have. So that first fraction, what was it missing? It was missing the married group x +2. So we're going to multiply by that on top and bottom. And so I'm going to distribute a 3 here, and I would end up with 3x +6. What was the second fraction missing? It was missing x -3. So I'm going to distribute a 5, and I'll end up with 5x -15. Now, when there's subtraction in the middle, remember last video we talked about changing that to addition and changing the signs of the things in the second fraction on the top. So then that way when I add like terms, I just have to worry about, adding them together. So I'm adding a 3 and then now -5x, which would give me -2x. And then I'm also adding 6 and then now +15. And that's going to give me a +22. 21. Yikes, where's my eraser? Whoa. All right, and then we still have the x +2, x -3. Now since the numerator, they don't share anything, I can't do an x puzzle or anything, this is my simplified answer. Okay, let's look at another one. Whoop. Whenever you can factor one of the denominators, that's what you should do first before we start comparing the two. So x² -4 is one of those special x puzzles. What multiplies to -4 and adds to 0? A 2 and a -2 will do it. So I'm going to just scribble this out all together and rewrite it as its factored form. X +2, x -2. So now compare the two fractions. They both have the married group x -2, but this first fraction has an extra group, an x +2. So remember, fractions can only gain, they can't lose anything. So I'm going to keep that first fraction as it is, and I'm going to have that second fraction gain the group x +2. So then they'll both be the same groups. Order doesn't matter here. So that first fraction, I'm not going to change it because it didn't change at all, so we're going to keep the 6x. However, the second fraction, it needs to gain the group x +2. So I'm going to multiply that on the top and bottom, and so then I'll distribute that -3. So I'll get -3x -6, and since there's a plus sign in the middle, I just need to combine like terms. So 6x and -3x combine to 3x. And then I've got this -6 over x -2, x +2. Now, the top here, I can factor. They both share a 3. So let me factor out that 3. And what would I be left with? X -2. And if you see what's happening here, I've got an x -2 on top and bottom, which is cool. So it says write your answer in simplified form. So you always need to factor if you can on your numerator, because sometimes this just might happen. I can cross something out, and so my final answer, I have a 3 on top, and I have an x plus 2 on the bottom. Okay? All right. Let's look at this guy. So we've got a married x, an x plus 2, and we've got a single x. So one's married, one's single. I can't say that they share an x, okay? So what I need to do, that first fraction, you're stuck with x plus 2, but you can make it gain a single x. The second fraction, you're stuck with that single x and just make it gain x plus 2. Okay? So this first fraction had to gain an x, so that's what we're going to multiply on top and bottom. So it turns into a 6x. The second fraction had to gain x plus 2. So we're going to multiply top and bottom by x plus 2. Then I'm going to distribute a 7, and I'll get 7x plus 14. Now, since they are like terms, going on a downward slant here, aren't we? Since these are like terms here on top, and I'm adding, let's just go for it. 6x plus 7x, that would be 13x. And then I just got to carry over that plus 14. Double check, can you factor your top? I cannot, so that is my simplified answer. All right, here, now let's see, we've got 2 married x's. They look almost the same. Are they exactly? Well, let's see, this x is positive, this x is negative. This 5 is negative, this 5 is positive. Okay, here's what we can do. In class, we talked about when they look the same, they're just opposite signs. We could take out a -1, and that would change the sign of everything. And so then I could flip-flop it, so then they would look the same. X was now positive, and 5 is now negative. Okay, so let me scribble that out, because here's what I want to look at. So now comparing the two fractions, they both have the married group x minus 5, but the second fraction has that extra -1. So the first fraction, it's stuck with the x minus 5, but it needs to gain -1. This second fraction, it doesn't lose anything, but it doesn't need to gain anything either. So second fraction isn't changing, okay? However, the first fraction, it needs a -1. It gained a -1. So we're going to multiply by that, and so that turns it into a -3. Now again, there's subtraction here, so I think we should just change the sign. And so when we add across the top, a -3 plus a -7 simply is -10 over -1 times x minus 5. Now think about simplifying. Well, there's really nothing I can do technically, but you have a negative number on top and bottom, so you should make those positives. That does cancel. So we would say we have 10 over x minus 5. Okay. Now we can't reduce 10 over 5 because this 5 is married with x, so we have to keep them as they are. All right, let's see here. Take a look at our denominators. Remember to square. This just means simply we have 2 of these t minus 3 groups. So if I compare top and bottom, they both have a single t. They both have a married t minus 3. But this first fraction has some extra stuff, a 2 and an extra t minus 3. So we're going to keep him the same. And to the second fraction, we're just going to add to him what he needs, or rather make him gain what he needs to be the same. So what does he need? He needs that loner 2 out front, and he needs another t minus 3. And so then that way, everything would be the same. So he'd have a 2, he'd have a t, and he'd have 2 t minus 3s. So we're going to multiply this in the red on top and bottom. Now, one thing you might want to consider real quick. this is a 4 times a 2. So it's probably easiest to think of this as an 8 that you're going to distribute. Okay? So we would have 8t minus 24. And this first fraction didn't change, so we're just going to keep 5t. Now we've got subtraction in the middle, so think about changing those signs. Okay? And then we can just simply add like terms. Ugh, I don't know why I keep doing this downward slant. So 2t, t minus 3, t minus 3. That's on the bottom. So now adding our like terms on the top, 5t and negative 8t. We'll add to, what will that add to? That will add to a negative 3t. And then I just have to bring over that plus 24. Now, what do these two guys share? Well, they both share a 3. But take a look at this trick I'm going to do. Since this 3 is negative, that's actually what I'm going to factor out. And so that's just going to change this plus to a minus sign, and it would turn into a minus 8. And so then let's see what we got after this. T minus 3, t minus 3. Oh man, I don't have anything that's the same to cross out. So this is my simplified answer. Got one more to show you. What's up with this guy? Okay. So remember to square it. It just means that there's 2 of them. I think I'll write them out just for the sake of space. So that's what that means. This guy can factor with an X puzzle, so maybe I'll do that over here real quick. A negative 2 on top and understood 1 at the bottom. What 2 numbers multiply to negative 2 and then add to a positive 1? Well, 2 and negative 1. So really let me scribble this out and write it as s plus 2, s minus 1. So then look at the 2 denominators. What do they both have? Oh, they both have s plus 2, but this one has an extra s plus 2, and this one has s minus 1. Okay, so that first fraction, it cannot lose those 2 groups. It just needs to gain an s minus 1. Because the other one had it, and it didn't. Okay? So I'm going to have to distribute here 8s squared negative 8s. Okay? Now the second fraction, it cannot lose its 2 groups either. However, what does it need to gain for it to be the same? It needs to gain an extra s plus 2. So we'll multiply by that on top and bottom. S plus 2, s plus 2. So distribute, and we would have 3s plus 6, and I forgot my plus sign in the middle. So then I would just add like terms across the top now that they're the same. So I'll go in order. We're going to keep the 8s squared. When I add the 2 yellow circles, negative 5s, and then plus 6 over s plus 2. I think I'm going to go ahead and write it as square again since we've got the 2 groups, s minus 1. Now I'm not going to have time to check, but one thing that would be worthwhile to check is to factor the top. Do divide and slide. See if you get an s plus 2 or an s minus 1, and then you could cross it out. But like I said, I don't have time in this video, so I'm going to stop here. Okay. The next video you might consider looking would be solving rational equations. So have fun, keep learning, and I will see you next time.